All right. Next one, I told you not to write all of this. Maybe just write the word increasing, decreasing, and constant. And then what I wrote off to the right. By the way, this is, what do we have so far? Function, not a function, domain, range, continuity. This is the fifth thing. Identifying where the function is increasing, decreasing, or constant. So these 2 days put together, these are all the things you're going to analyze in a graph. Plus there's more. Okay? All right. What these words describe is the range. What they describe is the y values. What are they doing? As you plug in x from left to right. All I'm trying to get you to identify is when you read a graph from left to right, what is your hand doing? If your hand goes up, the graph is what? Increasing. If my hand goes down, it's what? Decreasing. If my hand goes straight across, it's constant. Fumble and a big bouncer. Nice. That was fun. Okay. Feel free to not write these down. These are in the book, and I want to erase what I have right here. Another fumble over there. And then rewrite this. Look at this graph. By the way, this looks like a cube root graph. You'll find that out later. As I read left to right, what are the y's doing? Well, what's this doing? Is it going up or down as I read left to right? Going up. But you want to make a note to self. It's increasing from negative infinity to infinity. The word increasing describes fumble, what the y's are doing. These are the x's plugged in order that make those increasing y values covered. The answer is the x's. I'll say it again on this next one. Well, not really. It doesn't show up, though. But what's my graph doing right now? What is my hand doing? It's going down. And it's decreasing when I plug in x from negative infinity to infinity. The word decreasing describes what the y's are doing. You name the x's. Last one, constant. And then let's move in on this one so that you understand exactly what is occurring. And there's a discrepancy on this book. We as a department, and it is an argument, but I'll get over that in a second here. So look at what happens here. By the way, what's my graph doing from here to here? Decreasing. Notice how it's named, though. And I cannot overemphasize this, and I'll mark you wrong so quick your head will be spinning if you do this wrong, because it's wrong. The word decreasing describes the y's. The y's decrease when I plug in negative infinity all the way up to negative 2. This is how you name the interval that it's decreasing in. You name the x's that you plug in to make it happen. So it's these x's plugged in this order that make the y's go down. So that's the answer for what is this decreasing at. Now, don't put a bracket on this. Here's why. At negative 2, there's a change in direction. You don't really include negative 2 as part of the decreasing. At negative 2, there's a change. So you really should have a parenthesis there. Some books put brackets, some put parentheses. Lockport made a philosophical decision that it should be a parenthesis because of that idea. So now what's happening from here to here? From here to here, what's happening? Constant. And it's constant from the x values plugged in negative 2 to 2, parentheses. And then what's my graph doing from here to here? Increasing. This is all I should have to do to describe this concept. It's one of the easiest of all these things for describing things about what's happening in a graph. Jump. I hope I was taping during that whole increasing, decreasing thing. I don't think I was. Oh, it's crap. Okay, let's repeat it all. Here's increasing, decreasing, constant. Here are the answers. Here's this, and then here's this. Let's do this one then online. Hey, everybody, what am I doing from here to here? Decreasing. Now, what you do is you name, again, one of those invalid answers. I should send you out in the weeds, sir. All right, negative infinity to negative 1. You name the x. Now what am I doing? Increasing. That's from negative 1 to 1 when you plug in those values. Jump. Jump discontinuity. What am I doing from here to here? Decreasing. Oh, you know what? That's this coordinate. I almost got freaked out there for a second. Because this still is at 1, and then this ends at 3 for x. So from 1 to 3, I don't think you really have to union that. You're just kind of listing intervals. It's not the same as listing what x values are true for a particular scenario. Anyway, what am I doing from here to here? Increasing. So that's from 3 to 5. And then what am I doing finally? Decreasing. So that's from 4 to infinity. The reason you just put parentheses is because I'm sorry, it's 5. Oh, I threw a y in there. Should be an x. My bad, dogs. From 5 to infinity. The idea of putting a parenthesis means really at 5, you'll find out the graph is simultaneously at that little moment actually constant, but you don't say anything about that. That's a calculus kind of idea. So I did tape something there. Wow, that was bad. Go ahead. Oh, man. Never was good at math. Nice call. Oh, no. It's decreasing from negative 50. Oh, to negative 1. I might have said negative 1, but I accidentally wrote 1. Good call. Thanks. Was a little mistake in the notes. Make a note to self. Because of time. Because of time. Just keep a note. Don't fall asleep back there. Okay, I'm just saying. Just don't. He said he's not. Good. Okay, if they ask you where are the intervals where it's increasing, decreasing, or constant, you're going to need your blank blank graphing calculator. And then you're going to have to, okay, I typed this in. This is strange. Then I type it, I get this, this, this. Did you see that wave? That was weird. Did you see that wave? Anyone notice that on the screen? That kind of freaked me out. Okay, and then also, just by looking at this has to be negative 1 on the x-axis. Probably something when I plug in negative 1 plus 1, something weird happens. And then this has to be 1 on the x-axis. What's my graph doing now that I look at this picture? Decreasing. But what is it decreasing? From what to what? Negative infinity to negative 1. What's the graph doing from here to here? Constant. From negative 1 to 1. What did I do wrong years back? Bracket. They really should be parentheses. It's weird that some books do one thing and some do another. That is true. We at Lockport firmly believe that it should be parentheses because there's a change in direction at that point. You really shouldn't include it as far as that is concerned. Blah, 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 blah. You can get the rest. And then you should understand that this is a parabola. And a parabola actually changes direction from decreasing to increasing somewhere. What you really should be able to do is know where that changes because this is in vertex form. What's the vertex? X plus 2 squared. So what's the x coordinate? Not 2, negative 2, and then minus 1, negative 1. That's something you did last year quite a bit. Okay, and that would alleviate you from having to use your graphing calculator. Is what that would do. You'd be able to make this sketch real quick and then understand at negative 2 comma negative 1 there's a change in direction. Or graph it and do what we just showed you in the last, with that range question. What could I find for this graph? Starts with an M? Minimum. And it's at the minimum where we change from increasing to decreasing or vice versa. Okay? So, you can see those answers. Feel free to look at them and make sense out of them. Oh, made a mistake, right? Parenthesis, parenthesis, back in the day. So we've actually already done this once. Did I ever do the polynomial dance? We're going to do it in Chapter 2. Remember polynomials. X to the third could either be this or this, right? Or an x to the fourth could be this or this, right? X to the fifth, x to the sixth, x to the seventh, x to the eighth, right? And behavior, if the highest degree is an even degree, it could either end up with both arrows to the left infinity and the right positive infinity, or down. If it's an odd degree, they end in opposite directions. Well, this is some sort of, hey, what's the degree of this polynomial that looks like this graph? Based off of that great dance, what is it, even or odd? Even. Those that didn't say anything, go sit out in the weeds. I'm tired of you sitting here and sucking up oxygen and not doing anything. All right, now, look at this picture. What is my hand doing when I go from here to here based off the last thing that we just did? Increasing. But now what's it doing? So there is a change in direction. For a parabola, it was called the vertex. For a multiple changing polynomial, and actually for a parabola, it's also called the minimum or maximum. They're called local or relative extrema. Can everyone say extrema? Which just means local or relative maximums or minimums. What does relative mean? Just means relative means simply this. Boy, this person's the best baseball player in Lockport. Does that mean they're the best baseball player in the world? More than likely not. That would be the absolute best player. But relatively speaking for this area in Lockport, that's the best baseball player. Relatively speaking for this graph, is this absolutely the highest Y value? Yes or no? No. Relatively speaking for this area, this little particular spot, that is a maximum. Correct? Relatively speaking, this is the minimum for this area. Why is it not the absolute minimum? Because this graph goes forever, what? Down. Actually, for this graph that I've drawn here, this can be called an absolute maximum because it is the absolute highest Y value for this picture. So it is called a relative maximum, but actually should be turned into an absolute maximum because it is the highest. When you have an odd degree, do you have any absolute maxes or minimums? Yes or no? No, you can't, because in an odd degree, it goes off, to infinitely high Y values to infinitely low Y values. Keep your focus. Was I taping? Thank them. Okay. What this next part is, with the answers just shoved in your face, I guess I will do 42. So let's put 42 on the calculator, and if you don't do it, again, you belong out in the weeds. You're your own worst enemy. And then you sit there and complain about poor old Mr. S. Worst teacher ever. I failed. What'd you do in class? I stared at ceiling tiles and looked at his awesome posters. Yeah, but he's the worst. The worst. That's what I did every single day. Terrible teacher. So now, your responsibility is to actually understand that when I type in this x to the third, I should expect what I expect to see. The polynomial graph where the graph ends infinitely up and ends instantly down to the left. Okay, and then understand that if I have to find all local maxima and minima, or this could be said, find all extrema. Can everyone say extrema? See, and again, if you didn't say it, you know what? Okay. You need to know that that term means find the maximums and minimums. I agree that it's not kind of fair. It's kind of a tough, weird, mathy word. So, be aware of that. But what you need to understand then is this, and again for the Inspire, here comes a compliment, Inspire. It is a little bit easier for you guys to find these changes in direction. So, second calculate. What is that, by the way, that I was going to identify? This one right here. What is this? That's a maximum. All right, so I'm going to do it on the calculator one more time. You want to calculate a maximum. And again, we're stuck on this, left bound for our 84s. You just need to go left of that hump, left of that hill, and press enter. I don't know why that would be a difficulty. It really shouldn't be. It's the way the calculator does it. I didn't do it. The Inspire is more effective. The Inspire, you just hit maximum and open up a shaded region, right? Now the two arrows are pointing at each other. Hit guess. All right. Now, I pulled this coordinate out. What you need to understand is this for writing this down, and you should be able to handle this. And actually what this identifies is also intervals where it increases, then decreases, then increases. So you could actually turn around and do that real quick. But here's what you need to understand. The x value is where the relative max occurs. Write that down. It occurs at negative 1.15. The relative maximum is 4.08. Because again, the word maximum is describing the y value. That is the highest y value locally. So where it occurs is labeling it with the x value. So where does it occur? All right, and then going back to the calculator on this one, second calculate, well, that other point's a minimum. Enter, and again, here's the minimum. It's somewhere around here. You want to be left of that because of how the 84 works. You want to be right of that because of how the 84 works. Then you want to just hit enter for guess. And then I pulled that here. So, this is the relative minimum. This is where it occurs. Understand that notation. Okay, and now what we're left with, which I think happened last year, exactly at this point. There's only one more thing to do, which is even and odd. Okay, so, to recap. Function, not a function. Domain, range, points of discontinuity, increasing, decreasing, extrema. That's all of it that we've done so far.